Hey guys, today we're studying Dalton's law of partial pressures. Partial pressure can be defined as the total pressure exerted by a single component in a mixture of gases. Dalton's law of partial pressure states that the total pressure of a mixture is all the partial pressures added up together. So if we have three separate gases, then we can simply add up the partial pressure of each gas to find the total pressure. We can infer that each gas in the mixture behaves independently, and thus we can relate the moles of gas, or the total quantity, to the partial pressure. And we can do that by simply manipulating the ideal gas equation, which we know as PV equals nRT, or pressure times volume equals moles times the gas constant times the temperature in Kelvin. And we can solve for pressure by simply dividing V, or volume, on both sides, which would give us pressure equals nRT over V. So we can relate moles to pressure by first finding the partial pressure of gas 1, which is just a hypothetical gas that we're going to name here. And we're going to put that over the total pressure of the mixture. And that, if we plug in for P equals nRT over V, would give us the number of moles of gas 1 times RT over V over the total number of moles of the entire mixture times RT over V. And because we have RT over V on both the numerator and denominator, we can cancel out those, and that would just give us the number of moles of gas 1 over the total moles of gas in the mixture. And we call this the mole fraction for gas 1, which is just the total number of moles of a single gas over the entire number of moles of the mixture. So mole fraction can also be written as just X in an equation. And it's just the number that expresses the ratio of number of moles of a component to the total number of moles in the mixture. So going back to this hypothetical gas 1, the partial pressure for gas 1 would be the N1 over the N total times the total partial pressure of the entire mixture to give us the mole fraction multiplied by the total pressure of the mixture. So let's look at an example real quick. So in the air around us, 78% of it is nitrogen gas, which we can write as 0.78. And the total pressure of our atmosphere currently around us is about 760 torr. So to find the partial pressure of nitrogen gas in the air, we just multiply 0.78 times the total pressure, which would give us 790 torr. 590 torr. And that would be the partial pressure of nitrogen gas. In this example, we have a mixture that's composed of 0.5 moles of CO2, 18 moles of O2, and 80.5 moles of argon. So to calculate the partial pressure of O2, if the total pressure of the entire mixture in the atmosphere is 745, we would first have to calculate the mole fraction of O2. So we know there's 18 moles of O2, and we have to add up all the other moles in the equation to give us the fraction of just O2. So that would give us 18 over 100, which is 0.18. And then we have to multiply the mole fraction by the total pressure, which we know as 745 torr. So 0.818 times 745 torr would give us 134 torr, meaning that the O2 in this problem has a partial pressure of